this installment of Tech on Tap with Electro Matic. So today's topic is optimizing your processes using IIoT solutions. Our presenters are Ford Cheeseman. He is the IIoT Portfolio Development Executive with Siemens Digital Enterprise. And myself, I'm Nick Scope, the Director of Strategic Alliances and Business Development at Electro Matic. It's a quick agenda, high-level introductions, quick Electro Matic update, what's new with us. From there, Ford will get into doing an IIoT introduction, talking about how Siemens views IIoT, how we can help, start talking about the different technologies that we can utilize to start your IIoT journey or help you take it to the next level. From there, I'll discuss a end-to-end success story. We help the customer get started utilizing IIoT concepts and some technology. And we kind of looked at it from a scalability perspective. So starting from nothing, where we took them, and then where could we go in the future. And then to close it out, Ford will talk about, okay, how do you expand what we've done? How do you expand your IIoT journey today? All the different new technologies coming out from Siemens, and what does that look like, and all the different things we can help with. And at the end, there'll be some time for Q&A. Also, this has been recorded, so just as a heads up, this will be recorded and posted to our website for download in the future. So with that, Ford, any opening comments?
No, Nick, would you like me to go ahead and get started?
Yeah, let me jump through a couple slides and then I'll pass it right over to you.
Sounds good.
Thanks. Just a quick update on Electro Matic. It's been a very exciting last 11 months. So we joined forces with SunSource, and SunSource is a leading fluid power, fluid conveyance, and fluid process value-added distributorship. They have over 200 locations throughout the US and over 3,200 associates. So since we joined forces in November, Applied Controls has joined forces with us a month later. They're based out of the Philly area and cover the Mid-Atlantic. They look very similar to Electro Matic. And then we've also opened up branches in Florida. And we're very excited to announce we'll open up our Memphis office next month. So our footprint's growing, our associate count's growing. So we're able to help you implement some of these technologies in our core Michigan, Ohio area, and of course now these new locations as well. Just a quick overview of our product lines. I think most people understand the different offerings from Electro Matic. The one I really want to focus on is our partnership with Siemens. For sure, it's our flagship line. We've been partners with Siemens for 25 years this year. So I was really excited about that. And then our other high quality product offerings that we offer from Electro Matic. And a real quick advertisement for our web store. So if you haven't checked it out, please take a few minutes and check it out at shop.electro-matic.com. A lot of different self-service functions that you can go through and utilize on the store. You can get an account set up. You can look at your open orders. You can look at inventory. Of course, that's a bit of a struggle for all of us these days, but once it kind of normalizes, you will be able to look at inventory and look at product information, a whole host of other things. So if you haven't checked it out, I encourage you, please take a few minutes, go check it out at shop.electro-matic.com. And with that, I will throw it over to Ford.
All right, thank you, Nick. Let me go ahead and share here. Okay, is my screen coming up okay?
It is.
Great, great. Well, actually, before I get started, I would like to say, thank you to Electro Matic for, hosting this webinar and for us doing this together. As you can see, we are very committed together in growing our business and working together as they continue to expand, right? So as a partner, an esteemed partner for 25 years, it's great to be able to service more companies out there as we see Electro Matic continue to expand. So really excited to talk about the industrial Internet of Things today, also commonly referred to as IIoT. And what we're going to be looking at is how to gain new insights and capabilities which allow you to optimize your production performance, right? And with that, industrial IoT, IIoT, there are many different ways of looking at it. And so I wanted to set the stage in terms of how we together at Electro Matic and Siemens view IIoT and bring it back down to a level that all of us are familiar with. So if you take the I out of the first I out of IIoT, we're looking at IoT, the Internet of Things. And so if we take a step back into the 20th century, and if we're looking at how to gain more information, deeper insights into, say, for example, our exercise routine, how is our human body, how is our body performing? And we would probably go about doing the old pulse check, maybe checking your blood pressure, going to your doctor on regular visits. But ultimately, at the end of the day, all this information is going to be stored either in your mind or on paper written down somewhere. So it's very, very localized, very isolated, and not connected with other tools that you might have available to you. So similarly, if we look into the industrial world, the industrial assets would not be as connected as they are today. So if you wanted to look into how the machine is performing or how your assets are performing, then you'd have to go check it out. Maybe if it's an even older piece of equipment, you're looking at chart recorders, but there could be alarms and such that you would only be able to get locally. So knowledge is locked away. There's a lot of information there that can be taken out and utilized to improve performance overall. And so if we look to today, we think back to IoT, the Internet of Things, your Nest thermostat, your connected refrigerator these days. But to exercise routines, if you utilize a smartwatch, you can very quickly gain insights into how you're performing. And so that could include your heartbeat, your pulse rate, what distance are you running, for example, and then that's stored on your smartwatch as an edge device. But you can take that information up into a higher level cloud and be able to compare it and pull it into other tools, such as, let's say you want to compare it with how you're performing to what you have had to eat this week. So that's just something that we're all familiar with, we see in our day-to-day lives. And if you relate that to your industrial assets, all that locked away knowledge can now be grabbed, processed either on the edge or brought up into more of a cloud-based system where you can gain deeper insights to improve that performance level based on being able to be transparent, see your information, and act upon it as well. And what I'd like to bring it to is the IIoT stack. So what you'll see is IIoT is a collection of technologies all about from the field and control level, connecting, collecting information, getting that to an area where that could be processed, whether that's at the edge or a cloud level, that you can gain deeper insights and be able to get that single pane of glass that you can look through and to see how your overall health of your production is going. And then furthermore, if you want to go beyond, say, out of the box applications, you can develop more customized applications on low code platforms. So as you can see, it's this whole hamburger stack of technologies that come together in really providing IIoT solutions. So with that, I'm going to pass this off to Nick to cover a little bit more on, especially that in the plant level, how to be more intelligent with your assets.
Great. Thanks, Ford. Get some presentation one. Okay, great. So from a high level perspective, Electro Matic's been helping customers come up with IIoT and solutions for over 30 years. So we started back, with the old school bingo board where it was a piece of Lexan that was color coded with a sticker on it, maybe a couple digits, backlit with a incandescent light bulb, and at the beginning of it was almost like a light switch turning it on and off for help, right? From there, we moved obviously into LEDs and different LED signs and form factors and such. So we have some older pictures of our equipment installed at a manufacturer of trucks headquartered in Dearborn, which I think everyone would understand what that is. And then down to the bottom left, we show different form factors of our LED displays. And then to the right, we also show some of our solutions that we can help with as well, from a power distribution panel to robotic weld cart to cables, connectors, and everything in between. So when we looked at our customer, they were, well, they are a tier 1 supplier. And this is a kind of a representation of what their production facility looked like. So it's a cellular manufacturing concept. Each cell could build multiple different part numbers. Material was brought to each cell via high-lows. They would check, the status of the dunnage, with the parts. Basically, guys would walk around clipboards looking inside the dunnage and then indicating, okay, we've got 5 pieces left. Now I've got to walk back to the warehouse, track down a high-low driver, have them bring part A to production cell B. As you can see, it was very inefficient. They also had some material just scattered about on the production facility floor. It wasn't optimized, but they had to get started somewhere. So we started looking at this and having some conversations with them about ideas and how we can help, right? Where do we start? How do we just make this scalable so we're not going to try to boil the ocean in one sit here, right? So from there, we came up with this solution and working with them, and how do we optimize what they're doing? So we first started, okay, how do we indicate visually throughout the facility that a worker needs material, a worker needs help? How do we start to communicate that? And then from there, how do we help to optimize the resupply, right? I mean, are we looking at, can we run conveyors through the place? That'd be extremely expensive. Maybe it's to start simple, right? Maybe we replace high-lows with trolleys and tuggers. And so now it's a safer work environment. We can bring material to the cells quicker. And then also we can clear up some floor space if we start storing material properly in the warehouse area, right? And then the increased floor space allowed them to put more production cells in, so they're able to produce more product utilizing the same production footprint. So win across the board on how this could look. So then we started looking, okay, how do we start to chip away at this? From a cell level, the simplest thing is, how does an operator just let someone know, hey, I need some parts, right? I'm running low. We're going to repurpose the guy walking around the clipboard. So how does an operator start to communicate this to the warehouse that I need some parts? So just a very simple system came up with using Siemens KP8. So basically, it's an 8 push button HMI on Ethernet that can then take this data and push it up to the Andon system and basically drive some stack lights. It's a very simple. Green's okay, yellow, I've requested something, and red means it's gone beyond the time requested and I need some help. I'm going to starve the machine. I'm going to starve the process. We need someone to do something quickly. And this just goes into a little bit more detail as far as how each push button can be configured to correlate to a certain part number. And again, the system was designed to be configurable, so it's not programmable. So no one has to bring out a laptop or dive into step 7. It is a very simple, easy to use system for the warehouse. So once you're in the warehouse, okay, how does this get communicated? So first we needed a scoreboard. The scoreboard's simple and on display, showing the queue of part requests from the production cells. So if it's in white, it's just saying, okay, it's been requested. Blue is an indicator showing that it's actually in process of being filled. Red means, hey, look, it's just past due. And if it's flashing red and it's at the top of the list, something's going on. Something's not right with filling that material. And then how does this work? So basically, we created a very intuitive HMI screen that resides on a Siemens IP67 HMI in the warehouse area. So there's no large enclosures of the mount, nothing, just have to bring in 24 volts and an Ethernet connection. And it could be wireless if you want it to be. So the warehouse part fulfillment person looks at the request, it picks one, and there the barcode opens up on the screen. It scans the person scans the barcode, scans the dunnage, correlates the two, and then it brings the material out to the floor via the tugger. All the settings are protected via password. Next screen actually shows what the HMI looks like. So from this central HMI, you can look at configuring each KP8 for all the different production stations throughout the whole facility. So you can change the allotted time, the critical time. You can add or delete part numbers based on that cell's production schedule, that day, month, year. So it's all very highly configurable. In addition, you don't have to get into the PLC code, so it's very user-friendly. From there, thinking about this as a journey, we started looking at, okay, what other things could we help them with? They started implementing the stack lights, the KP8s, the Andon system. And start talking about how do you communicate from the ERP system to the production floor? How do you start pushing and pulling data? Could you actually start doing this where it's auto ordering parts from your supplier to start bringing to the production floor? How do you remove dunnage? Is there any ability to start using conveyors in the system? Do we use an HMI instead of a KP8 to give us more flexibility at the material call centers in the actual production cells? And of course, how do we start bringing this data up into MindSphere? How do we get it on tablets and phones and make it available and make it digestible for all the different people that possibly could want to see the insight of the different data points and what the production facility is actually producing. So here's some pictures of the real life version of it. So you can see just down each aisle, it's very easy to identify the dunnage, where the parts fill is, if everything's okay, or if the operator's waiting for something. Picture of the Andon board in the warehouse area, what part numbers are in queue, which ones are issues, who's doing what, and then be able to repurpose warehouse employees to production to increase throughput, and kind of talked about the different visual aids. And then this is just a kind of a straw man sketch of what the system looks like. There's a data concentrator that's basically a black box. It doesn't interfere with any of the production automation. We're just capturing data and insight from all the different KP8 entry points, from the barcode scanning. And then at the bottom, it shows we could do this on any system, regardless of PLC or automation family, regardless of robot. And then we can take all these different pieces and parts of IIoT and start having a conversation about what are the next steps, and how do we get this into MindSphere, and how do we use all these great Siemens technologies to really optimize the process. So from there, I will pass it back to Ford, and he will start to talk about some of those concepts.
All right, thank you, Nick. Here, let me share my screen. Okay, so, and thanks for going through that, Nick. And as you can see, it with what Nick had shared is that this journey, this IIoT journey, really starts at the plant floor, at the process level, working to optimize the processes there, as they have done in that use case, with more intelligent, basically utilization of that data that's available to make sure that these different cells are getting material on time when they need it, and reducing the overall downtime and increasing output. And so then the question becomes, okay, so then how can we expand beyond the plant floor with this information, and take this information from either, say, a brownfield or a greenfield plant, and connect that to, say, edge devices if you need something that is to be processed locally, move that information to the cloud, where then it can be compared to other facilities, where best practices can be shared amongst different facilities, different lines. And so that's really what we're going to be diving into a little bit more here. And oftentimes a question that we get is where to start. And we find that the best place to start is where the low hanging fruit lies, and that's where the biggest issues that we're seeing in processes. What are they? Where is the biggest bang for the buck? And so that's typically you pull production and automation information, such has been done with those and-on systems, and you start to leverage that to see increased uptime, increased production, right? But then at the same time, after we've picked those low-hanging fruit, it's a matter of now how do we get even greater insight into the many different facilities and lines that we do have across the world, right? And being able to pull this information from not only one site but multiple sites can put it into, again, that single pane of glass where you can get a quick view into how production is going at many different locations, how your process performance is at many different locations, or even if it's as an OEM machines, how are they performing at many different locations? But with the greater amount of data, you can gain greater insight and then tie this to organizational KPIs, and that will then feed back into how do we continue to improve in the many different areas. Again, downtime, overall equipment effectiveness, availability. These are all different focus areas that we see quite often. And so once you do get this information in an area that it can be visualized, it's then easy to pull up, say, for example, dashboards, as you can see here, that will provide the real-time insights into what is going on in the different lines, in the different facilities, and understand where the shortfalls are, and so that you can receive notifications to quickly respond and react to these, and even move from a reactionary standpoint to a more proactive standpoint. And we'll talk about that in a little bit here. So as I mentioned, this is not always going to be just an end user type of solution. It's IIoT is across industry. When it comes to equipment manufacturers, OEMs, there's many different reasons that we see OEMs implementing IIoT solutions. That includes being able to increase the efficiency of their service. As the experts of the equipment that they're supplying, we've actually seen OEMs become more consultative to the end users by being able to provide information that will help to preserve the capital equipment in turn, which would lower the potential warranty expense, but also in coaching them through how to best utilize the equipment to achieve the most out of that investment, right? But then from the end user point of view, it can also be looked at from, as we've talked about a lot, how do you increase that uptime? Where is your asset availability? How do you then optimize which assets are being utilized and increasing the efficiency of maintenance? For example, moving from a periodic maintenance schedule to a more on-demand maintenance schedule that would allow you more time in production with each machine or each one of your assets. And so with that in mind, what I would like to go into is a couple success stories that really highlight how IIoT solutions have been utilized by different companies. The first one being an OEM, Hasakawa Micron, which produces powder processing machines. Now, Hasakawa Micron realized that they truly are the experts in this field of powder processing. Although their equipment goes into greater processes for the customers that they're working with, ultimately they are the expert when it comes to this powder processing process. And so with that, what they've been able to do is become more consultative in helping to, one, observe, so being able to get the transparency into the data, but then also utilizing that data to help their customers improve their uptime by understanding, are there bottlenecks in the process? Is the machine being completely utilized to its full capacity? And then furthermore, when we take it into a more sustainability discussion, we look at how much energy is being used by the machine. Is there excessive energy being consumed when the machine is not operating? And how could they help the customers that they're working with to then improve their sustainability measures? So as an OEM, they became more value add, and they were able to also provide a better service to those that they are working with, which then led to differentiation in the market. So this technology was also utilized with MG Motors. And MG Motors is a vehicle manufacturer. They were experiencing basically an underutilization and a, let's say, not ideal throughput that they were trying to achieve when it came to their paint shop operations. Sometimes there was a backup of vehicles that needed to run through the paint shop. Sometimes the paint shop was going underutilized. There were no vehicles coming into the paint shop. And so by being able to take a look at the performance, one through their smartphones or a laptop, by being able to easily access this through the internet, they're able to get a very clear view of how they're performing to these KPIs that they have set as a goal that they want to achieve. But furthermore, they were actually able to pull this information from the paint shop machines and assets there and feed this back into a simulation that they had created, so that then they could understand in the virtual world what's the bottleneck, and then test and verify the changes necessary to increase the throughput in the real world by utilizing that closed loop digital twin, by feeding that information back into that simulation process, so that they didn't have to scramble on the actual plant floor to make these changes. They tested in the virtual world, implemented in the real world, 15% increase in throughput. So these are two examples. There are many more, and be happy to share them if you all would like to discuss this further, myself and Electro Matic. And I'd like to touch on here, how did Hasakawa and how did MG Motors, how did they really get this system to be operational with the given assets that they had? Well, there's a couple different approaches. Certainly, you could go. There's the hardwired route, which is where you would utilize, say, an IoT gateway or an edge device that would then be able to interface with existing equipment. And I have included some common protocols down here in the bottom left, just to show that it's very interoperable. It's designed to work across different vendors. Obviously, the Siemens hardware is designed to seamlessly integrate, but although we have drivers to basically integrate into these other protocols, but in some scenarios, you're not always going to have that hardwired connection. And so when it comes to needing to go cellular, which can save you on running cables and conduit, or maybe you're in an area where you don't have a hardwired internet connection, we also have packages that would help support you with data plans from Verizon and AT&T. So we really thought this out and trying to make it as easy as we can by putting these into packages for you. And going back to some of the use cases, so when we're talking about that low-hanging fruit and where we typically look, where OEE is typically the number one stop. Overall equipment effectiveness, factor of availability, downtime, utilization, a couple other key measures as well that you can include in there. But certainly maintenance is a big one that we see, being able to be alerted ahead of time proactively if there's potential for something to fail. And you can take it further into even sustainability, as we saw with Hasakawa. And at the end of the day, what we're able to do is build this out into starter packages, so that getting involved in getting started on this IoT journey is not a difficult process. It's a matter of we help work with you in terms of figuring out what are the right tools, everything from the andon and the HMIs that Nick was talking about, up into the connectivity, into the cloud, necessary applications, and even services if you would like for us to help deploy this within your environment. So with that being said, I would like to change gears here a bit and invite you all on the call to one of our new deployments of our digital enterprise experience centers, which is probably local to many of you. This is LIFT in Detroit, and it is still at the final stages of being completed. However, we are hosting there for meetings to have digital transformation discussions, so you can see the new technology that's out there that are really helping companies to innovate and stay ahead in the world of digitalization. So we did this in collaboration with Electro Matic and some other companies, and it's not only Siemens, there are many other innovative solutions that are showed there. So I hope that was a good taste for everybody when it comes to the industrial Internet of Things. Really bring it into what builds what makes up IIoT when we look at it from Siemens Electromatic standpoint, and would like to open it up to any questions that we have from the group. And thank you all very much for your time this morning. And this is my contact information and Nick's as well, if you would like to follow up and have any other further questions. But please feel free to unmute your mic if that's possible, Amy, for those in attendance, and ask any questions that you might have.
All right. Well, that was a great session, Ford. Appreciate the info. And I think, as Ford mentioned, please reach out. This will be available for download. So if you want to, share it with your teams or revisit it, or, if a question strikes you later today or whenever, please, reach out to Ford, myself, or your Electro Matic or Siemens account representatives, and be more than happy to engage in the conversation about your individual IIoT journey and how we can help. All right. I guess with that, again, thanks everybody. Have a great day, and we'll talk soon.
Thank you, everybody.
Thank you.
Have a great rest of the day.